Hi there, my name is Michelle and I will be your presenter today when we discuss the Changing the Maths conversation with Mangahigh. So I've been working with Mangahigh for a number of years now, working with students and teachers in the maths classroom for the past 7 years in fact. As the teacher success coach, I'd like to think that I help teachers embed their Mangahigh use effectively so that both the teachers and students are benefiting from having access to Mangahigh. Now that said, the biggest lesson I have learnt in my time in the last 7 years is the way that our students have changed their expectations in terms of the way they use technology. Now the reality is when technology was first introduced in classrooms, say 10 to 15 years ago, just placing students in front of a computer, even just to answer maths questions that they would otherwise complete in a workbook or a worksheet, was a very novel experience to them. Now, we were simply substituting the way students learn maths by using technology. Today, our students are a lot savvier with text. That's why we need to consider how the technology actually changes the way our students access maths, not just accessing it, but the way we inspire students to believe that they are maths people, though they may not know it yet. So today what I want to share are some ideas on how we can use Mangahigh to modify the way our students learn, and for teachers how Mangahigh can help redefine the way you teach. So you're not just using Mangahigh as for the lack of a better term, a babysitting tool, or on a Friday afternoon when it's time to wind down, but in fact actually integrate it effectively into your teaching practice so that you can benefit a lot from it as well. Now lastly, we really want to have this discussion around how students can be more responsible for their own learning and the tools available to them on Mangahigh so that they can own their own learning. To start with, here's a graph that I've taken out of a 2015 report from Grattan Institute titled Targeted Teaching: How Better Use of Data Can Improve Student Learning. Now, we're really good at collecting data. I mean, we could be better, but what we could be even better at is actually using that data that we have access to and doing something about it. But what's really important is this graph really stopped me in my tracks, as it is quite alarming. The yellow bar chart on the top represents a Year 4 classroom. Now, we all know that the Australian curriculum assumes that each year a student goes to school, they should be making 1 year worth of progress in their learning. However, in the Year 4 classroom that's represented here, we have a spread of students ranging from Year 1 through to Year 6. In fact, the highest number of students are actually below or 3 to 4 years behind. Now, these students typically would progress to the next year level anyway, even though minimum standards have not been achieved. So we keep going until we reach Year 8 in the orange charts, and most students are now below standards. Now, I believe that effective use of technology in a way where technology was designed with a student-centered approach provides a really good step forward for many students in terms of owning their learning and actually being engaged in their learning. So as a start, how do we use technology to modify the way our students learn so that they actually want to learn? So we know that technology can provide this context or environment where students improve their engagement so that they are more committed and they are more persistent. With these attitudes in place, we have a better chance of having students actually remember the contents they have learned in previous years in order for them to advance and build upon these as they progress through school. So when we learn, information from our working memory in our prefrontal cortex is then travelled through to our short-term memory, and finally it's propagated. Now, when I say propagated, it means we want to embed it into the deeper parts of our memory. But what's really interesting is that condition for propagating is that excitement, that fun, that engagement, and that's just general flow and focus in learning. So this creates a situation where the information or the signals is strong enough so that long-term memory is actually formed. Now, as we all know, learning maths has this predefined or somewhat predefined set of scope and sequence, which relies on prior knowledge, and each consecutive year we build upon that. So it's really important for students to actually remember what they've learnt. Now take the basic times table as a basic example. So traditionally we would do it in a worksheet. We might have some kind of a rhythm or a song for it. Or students see something like this in a worksheet and then, now how do we modify that? We might get more creative with our worksheets. Or we could put the same questions on a static computer screen. Or alternatively with Mangahigh, what we could do is actually put it in a game context where answering the correct or providing the correct answer adds an ice cream scoop to your stack. And then you're competing to build the highest ice cream scoop. So it's a lot more interactive, it's a lot more engaging, and it provides some context for your students to answer the questions. Now the important thing is, if they get a whole series of questions correct, and the questions automatically get harder. Now there are 3 stacks of ice cream stacks in this game, and you're responsible for the middle one. But we're competing against the computer by each side. So we build motivation and engagement and encouragement so that your students can get better or answer more questions correctly so that you can build a higher stack. You're competing against the computer. Now in fact, each round of this game runs for 90 seconds and students typically answer around about 100 to 120 questions depending on how quickly they are. But they are answering questions to build a taller ice cream tower. So there's commitment. But along the way they happen to be learning maths. Now, what's really interesting in this game is how we use mistakes. Now, instant mistake recognition, then putting the mistake back into practice so that you affirm that you've actually now got the right answer. That's really powerful for your student psychology towards growth building. It makes the struggle feel productive, which further leads to persistence and commitment. And before you know it, in around 10 minutes, students have mastered their table. You should try it. Now, students also get to acknowledge their own progress. And I like this idea of closing the loop between mistake recognition, reapplying your new learning, so you confirm back to yourselves that you have actually learnt it. So that's quite powerful. In contrast, in a worksheet environment, you may get a worksheet, you answer as many as you can, and it gets marked, and you might see some crosses where you kind of look at it and say, oh yeah, you've got a few crosses, but that's okay. We've got most of it right. And what do you do next? We move on, right? We haven't actually closed the loop. So it's really important for you to close the loop between mistake recognition, reapplying it so you prove it to yourself that you've actually learnt from it before you move on to the harder questions. So we looked at times tables, but the examples go on from basic tables in your lower primary. Well, let's hope it is in the lower primary, but the reality is, even working with a lot of secondary students, we have found that your year 8 or even year 9 students still don't know or comfortably have that sort of basic number skills flow automatic yet. So I think that if you're a primary school teacher, get on to times tables. If you're a high school teacher, still assign some times table games just to make sure your students are feeling comfortable and confident with it. Anyway, so looking at angles, so same thing, we have worksheets examples where your students will answer as many questions as they possibly can, skill and drill, which is great. So in upper and primary or even in lower secondary, that's what it looks like. However, in a game environment, this is what it looks like instead. So it's the same thing, you put the angles in a game, it solves a problem, and in this case the context is Itsy, the spider, falls into the warp and progresses the students into harder levels. Now the interesting thing to think about in a game is students naturally want to pass the level, right? So they don't feel like they're kind of just getting the task or the activity over and done with, but they pass a level so that they can move on to the next level where the surprise is harder maths work. But it's fine. It's interesting. It's an interesting challenge. So we have modified the way students learn. They are actually seeking out the next challenge where they're seeking out harder maths work. And again, the examples continue in upper primary. Same thing, we can either do maths, we can either do quadratic factorizations in a worksheet over and over again, or we can do it in a game format where we send out a rescue helicopter by telling the helicopter where the rescue location is by factorizing quadratics. So the examples go on. All in all, using a game mindset modifies the way our students think about maths learning. From prime factorization to number lines or to ordering fractions, decimals and percentages, they are engaged, while the game automatically adapts so that they do harder work when they're ready. And because of their persistence and commitment, it leads to long-term memory formation. But they're not doing the same level over and over again. It gets harder and harder. So as a teacher, how does this fit into your work routine? So of course, the games are really exciting for the students, but it's also very easy for teachers to assign so that you can create this to-do list of games that are still mapped to the curriculum so that they are not doing games that are way too easy for them, and you can track their results and analytics so you can see how well they're doing. Have they reached curriculum standards? So as a teacher, all you need to do is jump into your teacher platform, click on Assign, and using that funnel filter on the top right corner, click onto it, and then select Games. Okay, and from there you can scroll down and select the year level, perhaps even the topic, so you can filter out games that is actually relevant to what you're teaching. And simply click onto the activity, click Assign, and away you go. So it's nice and easy. Now, on a regular basis, we generally recommend a ratio of 1 game to 2 to 3 prodigy activities. The reason for that is you want your students to be committed maybe in the first 2 to 3 minutes of playing a brand new game to actually learning the game mechanic, and then spending the rest of the time that week when playing games to actually get really deep into the actual game itself. So you don't necessarily want to be assigning 2 or 3 or 4 games so that they have like a fleeting experience of those games. You actually want them to commit and work through it a lot harder. So for teachers, now that we have found a way to modify the way our students engage with maths, let's think about how we use technology to redefine the way you teach. So you're not just assigning tasks and then letting the computer babysit your students while you do other work that you are, I'm sure you're quite busy with. But you can actually use technology for a lot more effective than that. So as a start, let's think about all the creative ways you can insert Mangahigh into your teaching life. Most teachers use it as in-class group activity, or perhaps in-class individual activity. You use the reports to monitor your students' progress and have they understood it. You could also use it as a whole class instructional teaching activity. So bring up one of the activities. For the first 5 to 10 minutes in your class, just go through it together. Now remember, the activities are adaptive, so even if you had assigned the exact same activity for your students, when they click play on their to-do list, they don't see the exact rerun of what you've just shown on the board. So that's really powerful. You can obviously use Mangahigh as your babysitting tool in limited capacity or in limited sense. But what's really important is, have you considered using Mangahigh as your pretest? We all know we use it to support revision. We use it as homework tasks, especially the recommended work. But using a Mangahigh as a pretest allows you to get your students to do a Mangahigh task as a homework activity, for example, in the case of a flipped classroom mode. And you come into class, or before the class starts, check the analytics. Have all your students passed? And start grouping your students into 2 groups. Those that have passed can progress to do a second activity that you've assigned them, and those that have not passed, spend 5 to 10 minutes at the beginning of the class and do some small class activities with your students. So using it as a pretest is quite nice and neat for you to integrate into your natural teaching. Now, we have also found that the most useful use of technology in class is actually to use them in short, structured bursts, rather than spending a whole class on a couple of activities that you've assigned, and so your students have free reign over 40 to 45 minutes of your class, but actually blend it as part of your teaching. So here's an example. Start with an initial introduction of the topic you're about to cover, or even just to provide some initial information around the games. Now that said, sometimes you might even get your students to dive straight into the game. The important thing is 15 minutes later, ask your students to pause the game and then round up your classroom and have a classroom discussion around the activity. What could you do? What couldn't you do? What have you found? What did you realize? Put an example on the board, and for transferability purpose, see if your students can answer it now. After that discussion, then continue for another 15 minutes. And at the end of the class, I always like to have a summative written assessment or a follow-up activity. So it could be a mini test or some textbook questions or some worksheets. And this will also help you, the teacher, ensure that they can transfer the knowledge into, I suppose, for the lack of a better term, more traditional maths representations. Now, while your students are working away in their 15 minutes time slot, take a look at the reports. Are there any students that need extra help? In fact, use the grid book and select today so you can see students who have achieved a bronze medal and those that haven't. So again, you can provide instant feedback and instant support for your students. So you're no longer waiting for that sort of mid-topic test that happens a couple of weeks after you started a topic. You can track your students' progress continuously so that you can continuously support them along the way before you actually wait for the test to come along. So accessing the report's really nice and easy. Again, jumping into your teacher platform, simply click on the reports. You can look at achievements, you can look at assignments, which are all the activities you've assigned for your students. You can also see if your students have attempted any independent activities in addition to those that you have assigned. So again, use the time filter there to your advantage. You might want to look at a summative one for this entire term while you're writing reports, or while you're in class, click on the drop-down menu and select today. So you can just look at today's reports or your students' progress today. Now, discuss your students' responsibility for their own learning. This is our third idea about changing the maths conversation with our students. We want to start getting our students to think about building a workflow that allows them to take on more responsibility towards their own learning. So we are showing students how to learn. We're engaging them in their own learning process, but in addition to that, we're also providing them with the tools to support this development. We're actually showing them how to learn as well as what to learn with. Okay, so as a start, when your students log into Mangahigh on their student page, they can access activities from 4 different areas. We know that the assigned tasks are obviously curated or put together by the teachers. We can also see a list of recommendations, or they can browse or explore extra activities, and they can play games through the Game Center. Now, we encourage students to work through the recommended tasks because this is a unique, personalized learning pathway for each student. In fact, all the data that the reports that I showed you earlier has been collected. This data is automatically analyzed by the Mangahigh system, and the AI, or the artificial intelligence built into the system, then pushes out further work for each student. And these list of further work or personalized work is found under recommended. So the reality is, as teachers, you are so time poor to even manually act on each piece of data for each individual student in your class. So the system now automates it for you. In turn, it provides even more data, which when you are ready to analyze for report writing, there's a more holistic coverage of what your students have been up to and how they're progressing through the curriculum. So the reality is, we always say the data is only as good as what your students put into it. So of course we want our students to be committed so that they are completing a lot of work on Mangahigh. And we also want teachers to think about using Mangahigh regularly so that you're not just using it as an ad hoc service, I suppose. You want the data to represent what your students have been up to from, during the term. We also discuss with students how to use mistakes as an opportunity for growth. We spoke about this earlier, but basically, if we show our students where they have learnt or where they have gone wrong, we then show them how to find the right answers. Then they can then put those new learning back into practice, so it affirms or proves to themselves that they've actually learnt from it. In a Prodigy task, the process is very simple. At the end of the 10 questions, you see a summary page. The red boxes represent the questions that we could not answer, or the gaps. Students can click onto it, click on Show Solution, and actually learn from it before trying again. So the Prodigy system automatically recognizes the level you're up to. So the next time a similar question pops up, you have a chance to put what you've just learnt back into practice, and you go through that mental proof that you've actually learnt and understood the concept. So this proof is further reinforced when you eventually move from a medium question to a hard question, or perhaps from a hard question to an extreme question. So students see their own growth, and that puts that productive struggle back into play again. So even though it was a little bit difficult, it's worth it because we've now moved up to the harder level. We also talk to students about reflecting on their own learning. So all those mistakes, all those red boxes that we looked at, you click on Show Solution, and in your workbook, draw a vertical line right in the middle of it, on the left-hand side of your workbook. Write down what the question was asking, what the solution is, or what the solution that it shows is, and so now you've worked it out. But on the right-hand side, reflect on it. Has your thinking changed about this question? What have you learnt? Why did you make that mistake to begin with? Maybe you just accidentally misread the decimal places or clicked on the wrong answer that has a similar answer. But importantly, these reflections then serve as a cheat sheet. So when you play again, when a similar question pops up, you get to use these reflections as a cheat sheet to help you answer those next questions, and hopefully then move you up from a medium to a hard, and eventually grow to an extreme level. So what you would have noticed with Mangahigh is growth is that constant conversation. So we don't want students to just, get things over and done with, but we kind of want students to think about, now that I've done this, what's next? You're constantly having that what's next conversation. So that goes along with even earning medals. So bronze, silver, and gold. So the minimum expectation is a bronze medal. And at the start of the activity, we get our students to think about, well, I predict that I will earn a bronze medal today, or a silver medal, or a gold medal. But after the challenge, the highest medal I earned after 3 plays is, let's just say, a gold medal, or a bronze medal, or a silver medal. But the idea here is bronze is the minimum expectation. If you answer 4 hard questions correctly, you will get a bronze medal. But you don't have to stop there. Get your students to think about, how about if I challenge myself again, and will I achieve a silver medal or a gold medal? Excuse me. So again, it's about getting our kids to think about growth. So I hope that gives you some ideas on how to change the maths conversation with your students in class, and ultimately see this change in attitude and motivation, and eventually improvements in results. So we believe that all students are maths people. I hope your students will start seeing that, and that your students will start owning it, owning their own learning. So we move from this sort of tired concept of I'm bored in a maths class, why is it relevant, to actually learning and remembering, so that they get some excitement out of their own learning. So my name is Michelle. I'm your Teacher Success Coach. Please feel free to reach out if you have any questions at all. Thank you so much for joining me this afternoon. All the best.